Alright, what's up, crew? 5-minute lessons are beginning, and today it's a big one. The graph of sine and cosine functions. I'm worried about the length, so let's get right back into it. Just remember this. The cosine of 0 is 1, and the sine of 0 is 0. Well, that is going to be important. The cosine graph starts up here. It reduces, it goes into the negative, then it goes back to 0, and then it completes itself back where it started when you get all the way around the circle. Whereas the sine starts here, it increases. Uh-oh, it's hard to do this by hand. Then it decreases. No, hold on, I'm undoing that because I'm doing a wrong shape. It increases, then it decreases, then it increases again, and it goes back to where it started. In general, when you're sketching these, always remember that fact so you remember where does the curve start. Don't believe me? Let's go to Desmos, okay? Oh. Should have paused the video. Sine x. Look at it. It begins down here at 0. It starts to increase, keep in mind, at pi over 2. So Desmos is already in radians. Sine of pi over 2 is 1. Now look at how that compares to cosine. Oh gosh. Oh, as we expected, cosine starts high and goes down. Okay? Sound good? Alright, now the tangent graph. Maybe you have learned this already, but the tangent of theta, that's the sine of theta divided by the cosine of theta. Did you remember that? Now, what else do we know? Well, let's remember this. What's 10 divided by 1? 10. What's 10 divided by 0.1? 100. What's 10 divided by 0.01? 1,000. What's 10 divided by 0.0001? I skipped a couple. Well, that's 10,000. No, that's 100,000. So what's 10 divided by 0? That's infinity. What? Yeah. The reason that your calculator has been giving you an error message all along when you divide by 0 is that it cannot write infinity. It's too big for it to process, and it blows up. So look, let's go back to our Desmos. Well, if we look at tangent's going to be funky. Look at it. Why is it so different? Well, because, well, notice this point right here. The sine and the cosine are equal, and look what output we have there. 1. Yeah, that makes sense, because we're doing sine divided by cosine. But look, cosine's on the bottom, so wherever cosine is 0, it's going up to infinity, and then instantly it goes to negative infinity on the other side. And that's going to be something you're going to have to think a lot about. I can't help you understand that in 5 minutes, but I hope this intrigues you. I really do. It's pretty fascinating. Okay? Shifting graphs. Luckily, this part will be so easy, but it's important. So, you already know what sine of x is. So what's sine of x minus pi over 2? Well, that's going to shift it right. Remember, you know this. Right pi over 2 units. Well, you got to be careful because I can't wait to show you what this looks like. I'm going to get rid of the tangent. I know you love it, but I'm getting rid of it. Now look, let's look at sine of x, and then let's look at sine of x minus, just type in pi. Okay, well that looks awful familiar. Now what if I did this? Oh man, uh-oh. That looks even more familiar, and watch this. It's the same thing. The minus sine of x minus pi over 2 is the same thing as the cosine of x. Or watch this. There's just so many ways we can do this. Take that away. What? No, 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 no. Don't show all this code. Ethan will break down my computer and turn it into a missile. Oh, what? Bang! Yes, this gets wild. So that's how you shift them. How do you shift them up and down? You know that. Just do that. Okay? All right, now one more slide. Amplitude. Amplitude is the distance between the center of the wave and the height of the wave. So if your wave is like this. Oh, that's a terrible wave. But anyway, there's the center of the wave. This right here, that is your amplitude. Okay? Amplitude. So, I mean, what's it matter to us? What happens if I hit X there? Well, what's the biggest that the cosine of a number can be? 1. The amplitude is 1. So if we want to make our curves like go up and down more, then you just multiply them, and that number out in front is indeed the amplitude. So here we got a sine x graph. How about 5 sine of x? Look at the difference, okay? How about 0.5 sine of x? And if you're into music at all, you understand that by altering these waves, we can change the properties of these waves. And if we attribute the properties of these waves to music, you're talking about higher pitches, lower pitches, auto-tune. That's the best I can do. Boom!